Three more examples here. We've got the first of them is another example of a difference of squares. It's just, again, presented in a pretty subtle format. So we've got y squared. That pretty obviously is a perfect square. But so too is x minus 3, that whole quantity squared. So by itself, x minus 3, of course, isn't a perfect square, but x minus 3 squared is. And so I'm going to use that same pattern of difference of squares that we saw earlier. So we're going to have y as the first piece in each of the two sets of parentheses. It's going to be plus and minus. And then the second piece in each set of parentheses is just going to be that x minus 3. And so we can just leave it like that. Or if we wanted to eliminate that extra set of parentheses that we see there, we can just say y plus x minus 3 in that first set, and then y, here we just have to be careful because we're distributing this negative sign, minus x, but then plus 3 in the second set of parentheses. And so there is our factorization. So just a very subtle way that we can see a difference of squares presented to us. This next one here is a difference of cubes. So 8 is a perfect cube, 125 is a perfect cube, hopefully we recognize those. Then of course m cubed and n cubed are both perfect cubes. So off to the side here I'm going to write down that difference of cubes pattern. We had it in our notes earlier. So that's u minus v times u squared plus uv plus v squared. So there's our difference of cubes pattern. And in this case, u is going to be the cube root of 8m cubed. So the cube root of 8 is 2. And then m cubed, the cube root of that is just m. And then our v in this pattern is going to be the cube root of this guy here. So cube root of 125 is 5. And then the cube root of n cubed is just n. So that means in my pattern here, anywhere where I see a u, I'm going to replace it with 2m. Any place where I see a v, I'm going to replace it with 5n. So that means my first set of parentheses is going to be u minus v, so 2m minus 5n. And then my second set of parentheses is going to be 2m squared, so 2m times 2m, be careful, that's 4m squared, so the 4 is because we have to multiply 2m times 2m, and plus we've got u times v, so 2m times 5n, we're just multiplying these two together, so we get 10mn, and then lastly we have a v squared, so we've got to square this 5n, so 5n times 5n gives us 25n squared. And again, we can try as we as much as we'd like to. That second set of parentheses is not factorable, so that is the best that we can do. This third one here, I'm going to leave as an Easter egg here in the notes video, and I will take the first 5 people from each of my classes to email me the correct factorization of that guy. I will give you an extra point on your quiz that we'll be taking at the end of this week. So moving on to the last 2 examples that we have here, we have a technique that's called factoring by grouping. And so the signal that you're going to be factoring by grouping is that unlike every other example that we've looked at, there are 4 terms to the polynomial that we're trying to factor. All the others have had 3 or 2 terms. Here we've got 4 terms. So that's the signal that you're going to be using this factoring by grouping technique. And so we've got it spelled out for us here. It's basically a 3-step process, all undistributing. And so to start off, we're going to look at the first half of the polynomial, and we're going to see what we can factor, what we can undistribute from those 2 pieces. So I look at that and I can see 4 and 8. I'm going to be able to undistribute a 4, and then I have an x squared that's in common with those 2 pieces. So left behind, 4x squared times what gets me back to 4x cubed? That's going to be x plus, and then 4x squared times what gets me back to 8x squared? I need a 2. So step 1, I have finished. Step 2 now says I'm supposed to undistribute from the third and fourth terms. So I'm supposed to undistribute from the back end here. And for this all to work out properly, for us to even be able to do step 3, I need to end up with this x plus 2 left behind when I'm done. If I don't end up with the same thing left behind after the second round of undistributing, then I either undistributed incorrectly in the first part or in the second part, or maybe even both. But as I look at this, I can factor out a 5 from these two pieces, and indeed I am left with x plus 2. So now we've completed step 2. And so then we've got to move on to step 3, where we're going to undistribute from these two separate parts. So something from here and something from here needs to be in common. And so this gets back to some of the earlier work in our notes, where we're not just restricted to undistributing a number or undistributing a variable or a variable and a number, but we can undistribute an entire set of parentheses. And so that's what we see here. I have an x plus 2 that's in common in both parts of this expression. So I'm going to undistribute that x plus 2. And so then after undistributing that x plus 2, we can imagine that those are now gone. I've removed those from each of the two parts of my expression. Well, what's left behind? From the first part, it's a 4x squared, plus from the second part, it's this 5 here. And so that is my factorization of this expression. So even though I had 4 parts to it, because I was able to go through all of these rounds of undistributing, I was still able to get to 2 binomials multiplying each other as the factorization. So we'll try that one more time, and then our long nightmare of factoring is over, until of course you start work on the homework. So again, I'm going to start off and I'm going to see what I can factor from the first 2 terms of my polynomial. So step 1. And so all we can get here is a y squared. So there's no number that we can undistribute, but there is a y squared that's in common. And so what's left behind? Y squared times y would get me back to y cubed, plus, and then y squared times 2 would get me back to 2y squared. And so again, as I said on the previous example, I've got to undistribute something so that I end up with a y plus 2 in the second half of my expression. So I look here, and I can see that I can take out a 9, but then that would leave me with negative y and negative 2, so why not factor out a negative 9? If I take out a negative 9, then I'm going to have a y in the first position in the parentheses, because negative 9 times y gets me back to negative 9y, and then positive 2 will be the second piece, because negative 9 times 2 gets me back to negative 18. And so now, hopefully, after having seen one just a moment ago, we can see that we have a y plus 2 that's in common. So we finished step 1, we finished step 2. Step 3 is now this last round of undistributing. So I'm going to undistribute that y plus 2. So basically think of it as those have been factored out. They have been undistributed away. And so now what's left behind inside the parentheses? Y squared minus 9. And if you're paying close attention, you'll notice that we're not quite done here yet. If I leave myself a little bit more room, the y plus 2 I can't do anything with, but y squared minus 9 is a difference of squares. So I'm going to be able to factor that one more time. So I'm going to have y and y as the first piece in each of the sets of parentheses. I've got a plus 3 and a minus 3 as the back end of each set of parentheses. And so now we've got that expression fully factored.